Good morning, everyone. How are you today? Let's start to solve worksheet number 2, page 65 and 66. Okay. Question number one, define the valency. What does it mean by valency? Valency is the number of the electrons that an atom gains or loses or even shares during the chemical reactions. This is the definition of the valency. What does it mean by the valency? It's the electrons in the outermost energy level that an atom, even metals or non-metals, that loses or gains or even shares in the chemical reactions. So let's write the definition of the valency. What does it mean by the valency? It's the number of electrons that an atom loses or gains or even shares in the chemical reactions or during the chemical reactions. In the chemical reactions. Question number 2, complete the table. Give me the electronic configurations of sodium Na11, magnesium Mg12, chlorine Cl17. The electronic configurations, we make the electronic configurations of the sodium, so it takes 2 and then 8 and then 1. Electronic configuration for the magnesium, 2 and then 2, 8, I'm sorry, and then 2. Last one, chlorine 17, so the electronic configuration 2, K energy level take 2, then 8, then 7. Then he needs the valency and also giving it the reasons. What is the valency of the sodium? Sodium, the outermost energy levels contains 1 electron, so it needs or tends to lose the 1 electron. So its valency is monovalent. Why monovalent? Because it loses 1 electron in the outermost energy level, 1 electron during the chemical reactions or in the chemical reactions. During the chemical reactions. So it loses 1 electron. Here, the magnesium is what? Magnesium is divalent. Why divalent? Because the outermost energy level contains 2 electrons, so it tends to lose 2 electrons. So its valency is divalent because it loses 2 electrons. Loses 2 electrons in the outermost, loses 2 electrons found in the outermost energy levels during the chemical reactions. Last one, chlorine 17, electronic configuration 2872. It tends to gain 1 electron. So its valency monovalent. Monovalent. Why monovalent? Because what? Monovalent because it gains 1 electron during the chemical reactions. During the chemical reaction. Question number 3, write the names of the following. Write the names of these compounds. Here, Al2SO4 by 3. The name of this compound is called what? Here, start with the Al. So, Al, it's the symbol of aluminum. So, it's aluminum. Aluminum SO4 atomic group called what? Called sulfate. So, this compound called aluminum sulfate. Aluminum sulfate. Number 2, CaCO3. CaCO3. Ca symbol of calcium. Calcium. CO3 symbols of atomic group called carbonate. So calcium carbonate. CO3. CaCO3 calcium carbonate. Number 3, Na2O. Na2O. Na, it is a symbol of sodium. 2O, Na2O oxide. So reacts with the sodium reacts with oxygen to produce sodium oxide. MgCO3. Mg, magnesium. Magnesium carbonate. AgCl, Ag, this is silver. Silver and chlorine. Chlorine, Cl chlorine. So it's called silver chloride. Silver chloride. Third paper, page 66. Write the chemical formula for the following. Sodium chloride. What is the chemical formula of the sodium chloride? Sodium chloride. Sodium sample is S. Sodium Na chloride Cl. NaCl. The valency of sodium monovalent, the valency of chlorine monovalent. So the chemical formula of sodium chloride NaCl. Number 2, sodium nitrate. Sodium, the sodium sample is Na nitrate NO3. Nitrate NO3. Valency of the sodium monovalent, valency of the chloride of the nitrate monovalent. So I don't write the valency because this is 1 and also the nitrate is 1. So the chemical formula of the sodium nitrate is NaNO3. Number 3, sodium carbonate. Sodium carbonate. So sodium Na carbonate CO3. The valency of sodium is monovalent, but the valency of chlorine is divalent. So I make what? Make crisscross. So the sample or the chemical formula of sodium carbonate is Na2CO3. Number 4, sodium hydroxide. Sodium Na hydroxide OH. Na monovalent, OH hydroxide atomic group monovalent also. So the chemical formula of sodium hydroxide in NaOH. Here calcium chloride. Calcium Ca. Start with capital letter C and then small letter Ca. Chloride Cl. But calcium is what? Calcium is divalent, but chlorine is monovalent. Chlorine is monovalent. So the sample is Ca. CaCl2. Trace cross, so Ca1, Ca take 1, and Cl take 2. Number 6, calcium nitrate. Calcium nitrate. Ca nitrate NO3. But calcium monodivalent, nitrate monovalent. So the chemical formula is Ca between brackets NO3, close the brackets, and take 2. So the chemical formula for calcium nitrate is Ca take 1 and NO3 take 2, but put the atomic group between brackets. So CaNO3 by 2. Number 7, calcium carbonate. Calcium carbonate. Calcium carbonate. Calcium Ca carbonate CO3. Calcium divalent, carbonate divalent. So the chemical formula, the final chemical formula is CaCO3. 8, calcium sulfate. Calcium sulfate, calcium Ca sulfate SO4. Calcium divalent, sulfate divalent, so the final chemical formula CaSO4. Last one, calcium hydroxide, calcium Ca hydroxide OH. Calcium is divalent, hydroxide is monovalent, so the final chemical formula is Ca take 1 OH by 2. Question number 5. Compare between acids and alkalis. Alkalis means bases. Compare according to its definition, according to properties, and give me some examples. Okay, acids. What does it mean by the acids? Acids, they are substances. What does it mean by the acids? They are substances that dissolved in water or dissociated in the water and then producing positive hydrogen ion. So they are, it's right, yeah, definition, they are substances that dissolves in water and produce positive hydrogen ion. Positive hydrogen ion. They are substances that dissolve in the water and produces positive hydrogen ion. What does it mean by alkalis or bases? They are substances that dissolve in the water but producing negative hydroxide ions. So they are substance that dissolves in water and produce negative hydroxide hydroxide ions. What are the properties of the acids? The properties of the acids, they are, its taste is sour taste, but the alkalis it's bitter taste. And the acids change the litmus paper into what? Change the litmus paper, change the red litmus paper into, change the blue litmus paper into red. Alkalis or acids change litmus paper into red, but alkalis change the litmus paper into blue. So let's write the acids. Acids, they have sour taste, and also change the litmus paper into red, but alkalis, they have bitter taste, and change the litmus paper into blue. Examples, give me examples about acids. Acids like what? Acids like HCl, like H, hydrochloric acid, hydrobromic acid, HBr, H2, SO4, sulfuric acid, HNO3, nitric acid, H3BO4, phosphoric acid. All of these are acids. But alkalis like what? Alkalis like Na, OH, hydroxide, sodium hydroxide, or Ca, OH by 2, OH by 2, calcium hydroxide, or KOH, potassium hydroxide. All of these are examples of alkalis or bases. Okay, last questions. Define the oxide. What does it mean by oxides? Oxides, it's very simple definitions of the oxide. They are resulted, or they are substances that results from combination between an oxygen and elements. Even this element is metal or non-metal. So they are substances that results from the combination between an element and oxygen. Even though this element is metal or non-metal. Examples like what? Like Na2O or Al2O3, like sodium oxide or aluminum oxide. Sodium oxide, Na2O, sodium oxide, or Al2O3, aluminum oxide. Okay, this is metal oxide. Reactions between sodium or aluminum, they are metals and oxygen. But Non-metal oxides like what? Like carbon dioxide, CO2, carbon dioxide, and sulfur trioxide, SO3, sulfur trioxides. They are non-metals. Here, non-metals oxide, sulfur or carbon, they are non-metals. Reacted between the oxygen. But NeAl, they are metal reacted with the oxygen. So this is metal oxides, but carbon dioxide and sulfur trioxide, they are non-metals oxides. Okay, thanks, middle one. See you soon. Goodbye.